Howdy, math neighbors. It's me, friendly neighborhood math teacher here, doing a math video with you. We're going to look at a topic that is closely related to evaluating functions, specifically composition of functions. Before we get rolling with the content, just to remind you that the power of videos is you can pause and rewind. And I encourage you to do that, especially when you're looking at the practice problems. So, getting into the idea we're talking about, we're looking at compositions. So compositions are when we take a couple of functions, maybe more, and we put them together in different ways. So there's lots of ways to do that. The one that we're specifically looking at is doing something like this, but we're not using numbers, we're using variables. So instead of, say, evaluating this function f at -4 for x, multiplying -4 by 2, subtracting 3, getting negative as our output, we're going to be putting in something like -5x or 3x minus 1. So our result is going to have a variable in it, just like our input will. And then our input is also going to be a little bit more confusing. It's not going to be -5x. It's going to actually be the name of a function. And relating this back to other things we've talked about, we looked at how we could compose a function with another function, like here with f and g. And what we agreed was we're going to use g to get 4. G was a graph. The input's 4. Looking at the graphed function, the output is 3. So g of 4 is 3. And then we repeat the process, but this time we use f with an input of 3. In the table, the output is 6. So you're going to be doing that same chain of events, that same combination of events. And that's going to get us where we need to go. So here's a couple of worked out examples. And something I think is really powerful in math, and you'll hear me say in a lot of videos, is the idea of thinking about what's new, what's the same, what's changing, why is it changing? Because that tends to reveal a lot of what we're trying to learn. So here we have statements f of g of x and g of f of x. So these are two separate statements. In this case, we're composing f with g by inserting, substituting, or replacing x with g. Here, we're doing the reverse. We're inserting, substituting, replacing x in g with f. So for f, we would put x plus 5 into all of the x spots because g of x is x plus 5. After we do that, we go from 3 times x plus 2. X plus 5 is now in the x spot, so it's 3 times the quantity of x plus 5 plus 2. Multiplying both x and 5 by 3 with the distributive property, 3x plus 15 plus 2. We have 3 terms. 2 of them are common terms. They get combined to make 3x plus 17. When we do f into g, 3x plus 2 is going right here in that x spot. So we have the quantity 3x plus 2 plus 5. So this is different from what we did here because we don't have a value to distribute. So we have the values 3x, 2, and 5. We have like terms again. This time the constants are 2 and 5. They combine to make 7. I'm going to show you several examples here in quick succession. They'll be completely worked out. I encourage you to attempt each example before looking at the answer. And then after I've shown everything quickly, I'll go through and talk about the examples. So here's the first page of examples. And the second page of examples. Third page of examples. And again, I know that was super fast. That was purposeful. That was just there so you could pause and check real quick if you've already tried them, or pause after you work them. So let's go into each example specifically here. So the first one, we're given f in G, and it says find f of G. So G is going to go into f, just like we would if we were dealing with values, not variables, not functions. So there's a few ways to write this. For this first one, I chose to write everything horizontally. So notice how I've got, in place of the x being multiplied by -8, -10x. That's because it says G is -10x. So -10x occupies the x spot, it replaces x. So I have -8 times -10x plus 3. When I multiply, I have two terms, positive 80x, positive 3. Those are not like terms, so I do not combine them. Second example, we have h and we have f, and it says find h of f. So f of x, which is 5x minus 1, that's going to go into h in the x spot. What does that look like? That looks like this. Instead of 2 times x plus 4, it's 2 times the quantity of 5x minus 1 plus 4. As both 5x and -1 are multiplied by 2, that's what this notation means. I get a 10x minus 2 plus 4. I have like terms, -2 and +4, 10x plus 2. It's the simplified answer. The third one says find g of f. F goes into G, so x minus 5 is going to occupy the x spot right here. We're going to insert x minus 5, both those things right in there for x. It's going to become 3 times quantity of x minus 5 plus 6. This time I chose to write it vertically. There's no difference. You can go horizontally across like I did in the first two, or vertically down like I did here. It's the same thing. You would just may prefer the way one works, or the organization may make more sense to you. So after distributing, we have this. Again, we have two like terms. They combine to make -1. This is the obligatory video reminder that if I'm going too fast, remember you have the power to pause, rewind, and make things work for you. One of the advantages over live teaching. Disadvantage, of course, is you can't really ask me questions, but we have what we have. Okay, number 4, we have f and g. We want to find f of g. That means g is going to go in the x spot. It's going to be a little bit different this time. I don't know if you've noticed something already here. Maybe you already tried this one. If you haven't, pause the video and try it. Coming right back, when you substitute the -3x, it replaces that x that's being squared. So that's a -3x to the power of 2, a -3x squared. They both mean the same thing. Both of them mean, remember, this is very important. We have -3x times -3x. The -3 times -3 makes +9. And then we have x times x, and we write x times x as x squared. As always, we consider like terms. There aren't any. That means we are done simplifying. For the next one, if you haven't tried it already, pause the video before you try. This time we're putting f into g. G is 4x, f is 2x squared minus 5. Notice how only the x is being squared. I know we say 2x squared, but if we meant the 2x being squared, there'd be parentheses around the 2x. It's a really, really fine piece of subtle, math notation, but it's very important to pay attention to. This one I wrote vertically, which is again, your choice, perfectly fine, however you want to do it. So instead of 2 times x squared, we have 2 times 4x squared. The 4 and the x are being squared, minus 5. Remember, anytime you see a power of 2, you can always expand it and write it out as the thing times itself. In this case, 4x times 4x. That's a 16, x times x. X times x becomes x squared. So we have 2 times 16x squared minus 5. 2 times 16 is 32. Once again, we do not have like terms. We have 2 terms in our final simplified answer, number 6. Pause the video, give it a try if you haven't already. We're doing f of g like it says in the directions. So this is what f of g looks like. Notice how there's something new this time if you didn't before. F has 2 x positions. So both of these x positions are going to get replaced with 6x. Notice how I wrote 6x twice. Again, the reason why is because x is written twice here. So what does that mean? Well, not a whole lot, because 6x squared is still 6x times 6x, which is 36x squared. So it's negative 4 times 36x squared. 1 times 6x is 6x. And then it's a big number, but that happens sometimes. Negative 4 times 36 is negative 144. So even though both of these are x's, one of them is x squared. And x squared is not the same variable as x. Okay. 3 more examples here. We're doing f of g of x. Again, pause the video, try it if you haven't already. Moving right in. When we substitute in x plus 4, x plus 4 is being squared. And what does it mean when x plus 4 is being squared? It means we have x plus 4 times itself. And when we have x plus 4 times itself, that's 2, count them, 2 distributive situations here. We have x multiplying x plus 4, and we have 4 multiplying x plus 4. Another way you could think about what's going on here, you can always draw some connecting lines to remind you that you have x times x, x times 4, 4 times x, and 4 times 4. I did them in the same order I said them. X times x is x squared. X times 4 is 4x. 4 times x is 4x. 4 times 4 is 16. So we have 1, 2, 3, 4 terms from multiplying out using the distributive property on this quantity being squared. Now, when we take stock, again, what we're thinking about is like terms. And in this case, we have 2 sets of like terms. We have the x terms, which combine to make 8x, and we have the 16 and the negative 8, which combine to make positive 8. Number 8 is right here. If you haven't done it already, please pause the video and try it out. Moving right in, when we substitute g into f, it looks like this. So 5x minus 1, that's g. It goes right here in the x spot. So it's 5x minus 1 being squared, multiplied by 3, subtracting 1, in that order, because that's what the order of operations tells us. So something that math teachers, math explainers in general, a lot of times we just say things in the correct way without taking time to necessarily explain everything that's going on, which is a bit of a mistake. So in every one of these problems, the order of operations was important. But one of those peculiar, obnoxious things about math is all of those orderings and rules and notation pieces and special considerations only matter when they matter. And if you're learning something, you don't know when those things matter. Makes it kind of hard to learn sometimes. But anyway, let's finish up number 8 here. So we have 5x minus 1 quantity squared. And I want to encourage you every single time. If you have something being squared, remember it is the thing times itself. In this case, it's 5x minus 1 times 5x minus 1. So you could write this a couple of ways. Again, you could do it as 5x times the quantity 5x minus 1 plus negative 1 times the quantity of 5x minus 1. You can also, if it helps you to just draw some kind of connection, you could write it out longhand 5x times 5x plus 5x times negative 1 plus a negative 1 times 5x plus a negative 1 times a negative 1. Any of these methods are acceptable. Do whatever appeals to your sense of organization. Regardless, we're going to meet here in some fashion. We have 25x squared from 5x times 5x minus 5x from 5x times negative 1 and negative 1 times 5x and a positive 1. The 3 we haven't done anything with, so we recopy. Likewise, the negative 1, we recopy that. But when we distribute the 3, we have this, or you could have kept these separate and said each one is negative 15x. Your choice, doesn't matter. They're still like terms. They're still going to get combined to arrive at the final answer here. One more. If you haven't tried this one already, please pause the video and do so. We're putting G into F, which means every X spot in G, every X spot in F gets a G. So we have an X spot right here. It's being squared. We have an X spot right here being multiplied by 2. Here's that first X spot. Notice how 2x minus 1 is being squared. Here's that second X spot. Notice how 2x minus 1 is being multiplied by 3. So I'm not going to take a lot of time expanding 2x minus 1 in the several different ways I mentioned. By the way, there's more. But remember, anytime you have anything being squared, if it's a monomial, one term, one number, a binomial like these last 3 have been, 7, 8, and 9, it's always that thing times itself, which means you can write it out longhand. Regardless, we're going to meet somewhere around here. So if you do the 2x minus 1 quantity times 2x minus 1 quantity, you get 4 terms, 4x squared, negative 2x again, positive 1. 3 multiplies both 2x and negative 1 right there. The 2 you could have used or not used, depends. But either way, you're going to end up somewhere around here. 8x squared minus 8x plus 2 plus 6x minus 3. So the negative 2x and negative 2x make negative 4x, then multiplied by 2. That's negative 8x. 2 times the 1 is 2. We have 2 sets of like terms. The negative 8x, the positive 6x, those combine to make negative 2x. The positive 2 and negative 3 combine to make negative 1. 8x squared minus 2x minus 1. That's what f of g of x looks like here. Quick recapitulation. Composition is what we're studying. It's an expansion of the idea that we began here. So I have 2 functions working together. They're combined. G of 4. In this case, we use the graph to get G of 4. Once we know that's 3, we use the table to get f of 3, which is 6. That's no different than what we were doing with our practice here, except for instead of having a nice number here, we have to use variables. And because we have to use variables, we get a final simplified answer that's not a single number. As always, pay careful attention to things that are new, things that are the same, and write yourself lots of really good notes. I think it's probably better to cross out work in notes than it is to erase, but do whatever you like so long as it serves your learning needs. Thanks so much for following along. I'll catch you in the next video.